Well, students, so this is my first video on S block elements. Hope you have watched all my videos, of previous chapters. So here I am with one of the most simple chapter, but yet a very important chapter, for NEET examination, wherein you can expect at least one question from this particular chapter. It will be very simple chapter. If you understand the concept, it is just like yes or no question. You can easily answer the question and you can get 4 marks in your NEET examination and 1 mark from your CET examination. So guys, what we have got to study in this particular chapter? Well, so here we will study some of the important physical, chemical and chemical properties of S block elements, and also we will study some of the compounds of sodium, some of the compounds of calcium. Yes, students, now let us study in detail about S block elements. So I hope you know that we have classified all the known 118 elements into 4 blocks, isn't it? We have classified all the known 118 elements into 4 blocks, isn't it? They are S block, P block, yes, D block and F block elements, isn't it? S block, P block, D block and F block elements. Well, in 11th standard we will study in detail about S block elements, 13th group and 14th group of P block elements, in 11th standard. Whereas in 12th standard we will be speaking about the 15th group, 16th group, 17th group and 18th group of P block elements, and then D and F block elements in 12th standard. Yes, so as I was telling you, yes, we have classified the 118 elements into 4 blocks. I hope you know the structure of the periodic table. You know that in the long form of periodic table, we have arranged the elements in the increasing order of atomic number in different horizontal rows and vertical columns. Hope you got it. Yes, we have arranged the known 118 elements in the increasing order of atomic number in different horizontal rows, and vertical columns. Is that correct? Vertical columns, isn't it? Yes. Hope you know the structure of the periodic table. We have 2 groups of elements. We have 2 groups of elements placed at extreme left of the periodic table. These 2 groups, group 1 and group 2. Yes, these two set of 2 group elements, they are called as S block elements. Hope you know this. And to the extreme right we have 6 groups: group 13, group 14, group 15, group 16, group 17 and group 18. Group 13 to 18. These set of 6 group elements, they are called as P block elements. Yes. These set of 2 group elements, they are called as what? S block elements. And in between S block and P block we have a set of a group 10 group elements from group 3 group 3 to group 12, isn't it? 10 groups. Group 3, group 4, group 5, group 6, group 7, group 8, group 9, group 10, group 11 and group 12. So these groups, the elements from group 3 to group 12, these elements are called as D block elements. And then we have set of 14 elements which are placed at the bottom of the periodic table. Okay, we have placed a set of 14 elements and 14 elements. This series consists of 14 elements. This series consists of how many elements? 14 elements. These two sets of 14 elements, they are called as what? F block elements. Hope you know this. They are called as what? F block elements, isn't it? Yes, 14 elements from this set. Okay, yes, and 14 elements in this set. Okay, so these two sets of 14 elements each, they are called as F block elements, and F block elements are placed separately at the bottom of the periodic table. Correct? Okay, they are placed separately at the bottom of the periodic table. So now, okay, our point of interest in this chapter is all about group 1 and group 2. Group 1 and group 2. Okay, now yes, group 1 elements and group 2 elements, they are together called as S block elements. Group 13 to group 18, these elements are called as P block elements. Okay, group 3 to group 12, these elements are called as D block elements, and two sets of 14 elements each which are placed at the bottom of the periodic table, they are called as what? F block elements. F block elements, isn't it? Correct? Okay, yes. Now, so we will fix our discussion, will confine our discussion only to two groups. Okay, which are those two groups? Group 1, okay, and group 2. What do you call the elements of group 1 and group 2 as? They are called as S block elements, isn't it? Correct. Okay, yes. So let us talk about the elements of group 1 and group 2. Yes, elements of group 1 and group 2. Look at here. Okay, please refer to the periodic table whenever I'm teaching you, okay, the properties here. Please refer the periodic table. Please have the periodic table in your hand. Okay, and then just try to correlate the property whatever I teach to your periodic table. Okay, clear? Yes. Learn the concepts. Don't cram the concepts. That means don't by heart the concept. Okay, don't by heart. Don't by heart. Okay, just learn the concept, understand the concept, and apply the concepts when you are solving MCQs. Okay, are you all able to understand? Yes. So I'll be talking about two groups of elements. One is what? Group 1 and group 2. Yes. Okay, in group 1, what are the different elements in group 1? In group 1 we have hydrogen, okay, lithium, then sodium, okay, potassium, rubidium, cesium, and francium. Okay, yes, in group 1 we have hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Okay, group 2, yes, here we have beryllium, okay, magnesium, calcium, okay, strontium, barium, and radium. Okay, please remember, please, okay, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, group 1. Beryllium, magnesium, calcium, strontium, barium, and radium. Okay, these two are group 2 elements. We know that the position of hydrogen is uncertain in the periodic table. We don't study hydrogen under group 1 elements. We study a hydrogen as a different element, as a separate element. That is why we have already learnt about hydrogen in a separate chapter called as hydrogen, isn't it? Correct? Hope you have watched those videos on hydrogen, isn't it? So we don't study hydrogen under group 1 elements. We study hydrogen, okay, as a separate element. We don't include it under the study of group 1 elements. Okay, are you getting my point? Yes. So that means in group 1 we just have to study about the elements from lithium to francium, okay, and group 2 beryllium to radium. Beryllium to radium. Understand my point? Okay, yes. See, we know group 1 elements are called as alkali metals. They are called as what? Alkali metals. Understood? Okay, group 1 elements are called as what? Alkali metals, whereas group 2 elements are called as, okay, they are called as what? They are called as alkaline earth metals. They are called as alkaline earth metals. Are you getting my point? Yes. So group 1 elements are called as alkali metals. Group 2 from beryllium to radium, they are called as alkaline earth metals. Okay, and please remember one more thing. Okay, the last element of each group, that is francium, the last element of alkaline earth metal, that is radium, these two elements are radioactive in nature. They are radioactive in nature, isn't it? They are radioactive in nature. That means francium is a radioactive alkali metal. Okay, radium is radioactive alkaline earth metal. Therefore, we don't have to study any reactions, any properties related to these radioactive elements. Okay, radioactive elements. So we don't study any of its properties, or we don't study any of its reactions here because they are radioactive in nature, and very less information is available in the literature about these radioactive elements. So we will not consider these radioactive elements in our discussion. So that means whenever we are dealing with the physical property or chemical property or any chemical reactions, we will be talking about only the elements from lithium to cesium of alkali metals, beryllium to barium of alkaline earth metals, beryllium to barium of alkaline earth metals. So we will concentrate about these elements, lithium to cesium and beryllium to barium. So note, francium and radium are radioactive in nature. Radioactive in nature. So group 1 elements are called as alkali metals, group 2 elements are called as alkaline earth metals. So guys, first of all, why these elements, that is group 1 elements and group 2 elements, why these elements are called as S block elements? Why are they regarded as S block elements? Any idea? Yes. Okay, if I have to call them as S block elements, I have to look into their electronic configuration. If I take lithium, okay, whose atomic number is 3, okay, and what is its electronic configuration? It is, come on, okay, 1s2 2s1, isn't it? The electronic configuration of lithium is 1s2 2s1. Look at the last electron. Okay, it contains 3 electrons, isn't it? And the third electron, that is the last electron, enters the last s orbital, isn't it? The last electron enters the last s orbital, correct? So you take any of these elements, okay, in any of these elements, the last electron enters the last s orbital. That is why they are called as S block elements. Okay, I'll give you one more example. If I take calcium, what is the atomic number of calcium? The atomic number of calcium is 20. Okay, what is its electronic configuration? The electronic configuration is 1s2 2s2 2p6 3s2, isn't it? Okay, 3s2 3p6, and then what? 4s2. Okay, 1s2 2s2 2p6 3s2 3p6 4s2. Look at the last electron. The last electron is entering the last s orbital. That is why calcium is an S block element. So in general, what are S block elements? Okay, look at here, the elements in which the last electron here, it is called as valence electron. The elements in which the valence electron enters the last s orbital. Last means valence. Okay, the elements in which the valence electron enters the valence s orbital are called as what? They are called as S block elements. They are called as S block elements. If the valence electron enters the valence s orbital, then those elements are called as what? S block elements. Okay, sure, clear? Okay, so in all of these elements, In all of these elements, the valence electron enters the valence s orbital. Simple, correct? Okay. Now, why are group 1 elements called as alkali metals and why are group 2 elements are called as alkaline earth metals? Okay, why are they called as alkali metals and why are they called as alkaline earth metals? Look here, okay, yes, group 1 elements, when they react with oxygen or when they react with, okay, what? Water. Group 1 elements, when they react with oxygen or when they react with water, they form, okay, yes, metal oxides, they form oxides and hydroxides. They form what? Oxides and hydroxides, which are strong bases. Which are what? Strong bases. Okay. When group 1 elements reacts with oxygen or water, they form oxides and hydroxides, which are strong bases. That is why group 1 elements are called as alkali metals. They are called as alkali metals. Alkali means what? Alkali means base. Alkali means base. Okay, simple? Yes. Now, why group 2 elements are called as alkaline earth metals? See, these elements also, when they react with, that is, when group 2 elements, okay, when they react with oxygen and water, they form what? Oxides and hydroxides. They form oxides and hydroxides, which are strong bases, and they are found in earth crust. They are found in what? Earth crust. They are found in earth crust. That is why they are called as alkaline earth metals. They are called as what? Alkaline earth metals. Alkaline earth metals. And I hope you have understood. Okay? Yes. Any doubts with this? So I hope you know now what are S block elements, why group 1 elements are called as alkali metals, and why group 2 elements are called as alkaline earth metals. Okay, now we will study some of the physical properties of alkali metals and alkaline earth metals. Before we talk about the physical properties of alkali metals and alkaline earth metals, let us understand the electronic configuration of these two group elements, because it is the electronic configuration, it is the arrangement of electrons, okay, which gives rise to the physical properties and the various chemical properties of these elements. So if I have to talk about any physical property, if I have to talk about any chemical property, okay, I will be making use of their electronic configurations. Therefore, it becomes very necessary for us, okay, for us to learn about the electronic configuration of alkali metals and alkaline earth metals. So let us talk about their electronic configuration now. Okay, yes. Let us talk about the electronic configuration. Yes, okay. Now, okay, we will be dealing with the electronic configuration, electronic configuration, okay, yes, of what? Okay, of alkali metals, and the next one, alkaline earth metals. So we'll be talking about alkali metals and alkaline earth metals electronic configuration. Okay, so alkali metals, we have what? The first element, lithium, sodium, okay, potassium, rubidium, okay, let me write it a little more up, okay, yes, we have lithium, okay, and then sodium, potassium, rubidium, cesium and francium. No doubt francium is radioactive in nature. We will not study about its physical and chemical properties here, but let us talk about the electronic configuration. That's it. Okay. So what about the atomic number of electronic configuration? See guys, if you can't remember the electronic configuration, at least remember this: 2, 8, 8, 18, 18 and 32. Okay, 2, 8, 8, 18, 18 and 32. Which was the first element prior to lithium? It was hydrogen, isn't it? At least you know the atomic number of hydrogen. What is the atomic number of hydrogen? It is 1. Now, okay, start adding those elements. Start adding those numbers. 1 plus 2 will give us what? 3. Is it correct? 3 plus 8, 11. 11 plus 8, 19. 19 plus 18. 19 plus 18, 37. Okay, yes, 37 plus 18, 37 plus 18, 55, isn't it? 55 plus 32, it is 87. 87. Just remember that at least. 2, 8, 8, 18, 18 and 32. Okay, whenever you are starting from the first group, first element, topmost element. Okay, correct? First period element. Clear? Okay, 2, 8, 8, 18, 18 and 32, which is called as magic number. Hope you have learned this in periodic table, classification of elements and periodicity in properties. Okay, now if you start writing the electronic configuration of these elements, what is the electronic configuration of lithium, which I have already written? What is it? It is 1s2, 2s1. Okay, sodium, it is 1s2, 2s2, 2p6, 3s1, isn't it? 3s1. Potassium, okay, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, isn't it? Is this correct? Okay, next rubidium. Yes, okay, 1s2, okay, 2s2, 2p6, 3s2, 3p6, okay, 4s2, okay, 3d10, 4s2, 3d10, 4p6 and then 5s1. Okay, is it 37? 10, 20, 30, 37. Yeah, that's correct. So now cesium, okay, like that it goes. Okay, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, okay, 4s2, okay, 4p6, 5s2, 5s2, after 5s2, yeah, come on, 5s2, yes, 5s2, 5p6, okay, 4d10, 4d10, okay, and then 6s1, 6s1, is it correct? Okay, yeah, 2, 10, 20, 30, 40, 40, 48, 48 plus 6, 54, 55. Yes, this is correct. Okay, now how about francium? Same, inner electronic configuration will be same, and at the end we will get 7s1. 7s1. Observe the valence electronic configuration of alkali metals. Okay, observe the valence electronic configuration of alkali metals. The valence electronic configuration of lithium is 2s1. The valence electronic configuration of sodium is 3s1. Potassium 4s1. Okay, rubidium 5s1. Okay, cesium 6s1. Okay, francium 7s1. The valence electron configuration, isn't it? Therefore, can I say, okay, or else I can also write the electronic configuration of these elements like this. Look here, 1s2 means what? It is nothing but the electronic configuration of helium, isn't it? 1s2, 2s1, yes or no? Correct. Okay, next, can I write, okay, look here, 2 plus 2, 10, okay, 6. From here to here, is this not the electronic configuration of neon? Yes, it is the electronic configuration of neon into 3s1. Neon into 3s1. I can write this electronic configuration as 10 plus 2, 10 plus 8, 18. 18 is nothing but argon. So I can write this as argon core configuration into 4s1. Okay, this is krypton. Okay, argon, krypton. Okay, 5s1. Next, this is going to be what? This is going to be, okay, xenon configuration into 6s1. This is going to be, okay, radon configuration into 7s1. Yes. So look at the electronic configuration of alkali metals. In the inner core we have noble gas configuration, and in the outer shell we have, okay, ns1 configuration, isn't it? Therefore I can say the general outer electronic configuration of alkali metals as, okay, yes, inert gas configuration, okay, inert gas configuration, okay, times ns1, isn't it? Okay, inert gas configuration, helium configuration 2s1, neon configuration 3s1, argon configuration 4s1, krypton configuration 5s1, xenon 6s1, radon 7s1. Therefore what is the general electronic configuration of alkali metals? The general electronic configuration of alkali metals is inert gas configuration, okay, and then ns1 configuration. That means inner orbitals are completely filled. For all alkali metals, inner orbitals are completely filled and outer orbital has one electron in the s orbital, isn't it? One electron in the s orbital. Any doubts with this? So like that, on the same lines, let us write the electronic configuration of alkaline earth metals. Alkaline earth metals. So which are the different alkaline earth metals we have? We have what? Beryllium, okay, yes, magnesium, yeah, calcium, okay, then strontium, barium and radium, isn't it? Here radium is an alkaline, sorry, radium is a radioactive element. What about their electronic configuration? Okay, 3, 4, beryllium 4. This is a second period element. From second, if you are starting with second period elements, you have to start with 8. Okay, add 8, 4 plus 8, 12. Then add 8, 12 plus 8, 20. 20 plus 18, what? 38. 38 plus 18, 56. 56 plus 32, yeah, 56 plus 32 is 88, isn't it? Okay, 88. Is this correct? Now, if you start writing the electronic configuration of these elements, okay, if you start writing the electronic configuration of these elements, what is this going to be? Yeah, okay, for beryllium it is 1s2, okay, 2s2. Okay, can I write this electronic configuration as, this is nothing but helium. So helium configuration into 2s2. Is it correct? Okay, for magnesium then it will be what? Okay, neon configuration, okay, 3s2, isn't it? For calcium this is going to be argon configuration 4s2. For strontium, okay, krypton configuration, okay, krypton configuration 5s2. Yes. So for barium, okay, xenon configuration 6s2. For radium, for radon, okay, yeah, it will be xenon, okay, helium, neon, argon, krypton, xenon and radon configuration 7s2, isn't it? Observe the electronic configuration, okay, helium configuration 2s2, neon configuration 3s2, argon configuration 4s2, krypton configuration 5s2, xenon configuration 6s2, radon configuration 7s2. Therefore, can I write the general outer electronic configuration of alkaline earth metals as, okay, inert gas configuration, okay, yes, ns2, isn't it? Here also in alkaline earth metals also, okay, the inner orbitals are completely filled. The inner orbitals are completely filled and the outer orbital has 2 electrons in s orbital, isn't it? The outer orbital has 2 electrons in the s orbital. So guys, this is about electronic configuration. Okay, now we will be talking about the various physical and chemical properties. So let me list out all the physical and chemical properties that we have got to study now. Yes, let us list out all the physical and chemical properties that we have got to study. Okay, yes, let me list out. So I'll be talking about these physical properties in the next video, but let me just list out and give you the clear picture. Okay, yes. So in physical properties, okay, so we will be talking about atomic radius, second ionic radius, ionic radius. Third one, valency. Okay. Fourth, ionization enthalpy. Ionization enthalpy. Enthalpy. Okay. Yes. Fifth, okay, metallic character. Metallic character. Okay. Sixth, melting point and boiling point. Okay. And okay, next, density. Density, very 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 important. Color to the flame. Okay, color to the flame. So we will be talking about these physical properties in the next video. Thank you.